Hi, this is John Spencer again. I've been walking through the elements of how to simulate dynamic field models using my 2020 current directions paper as an example. We just finished walking through the sim file, and I'm going to turn my attention now to the GUI file. GUI just stands for Graphical User Interface. And this is the part of the collection of 3 simulator files that basically displays the model as it's running. I'm going to go through this relatively quickly because there's a lot of kind of detailed coding here. When I set up a GUI file, I always just copy example displays that I've seen in other simulators. So for example, if you go to your Cosavina folder in GitHub that you've downloaded from the GitHub repository, you'll see an examples folder. If I click on that, I can, this is just a bunch of different simulators we developed to go along with our book called Dynamic Thinking, a Primer on Dynamic Field Theory, published by Oxford University Press, in case you're interested. And you can load any of these models, let's say, into MATLAB and run them. And when you run them, all of these models have a GUI built in. And you can do things like, this is just a sample 2-layer model where you can set up parameters and sliders and funky things like that. Again, I'll refer to the book if you want to get into these details. I highlight this now simply to show you that if you go into these launcher files, they consist of basically the contents we would put into a sim file, which I just walked through in the previous video. And then they'll also have the contents we put into a GUI file, which I'm going to walk through in a minute. And so you can pull up any of these launcher files, run them, and if they have a display like what you're looking for when you're building your own dynamic field model, you can look at the code used for the GUI portion of the simulator and copy that into your GUI file and essentially construct a nice display for your dynamic field model using other examples. The nice thing about that is you really don't have to create this code from scratch. We've kind of done that for you. So the way I built the GUI file for this 2020 current directions paper was literally by copying code from those launcher files and assembling it into a nice pleasing GUI. If I run my simulator, I'll just show you what the GUI looks like, and we'll pull that up and then walk through the code. This is my graphical user interface here. You can see I'm displaying the field activity up in the top using a type of MATLAB plot called a mesh plot. And it's going to actually, as I run this, you'll see it'll move through time. So it's like it's going to display that running history that I created in my simulator. In the middle here, I'm going to display the current time slice through the field. So you can see the blue line is the field activities. The red line is the sigmoid on those activities, so any site that's currently above threshold. And the cyan line is the memory trace. And then down below, I'm plotting the interaction function, which is that local excitation surround inhibition function that I walked through in the simulator. My GUI, you can see, also has a number of buttons down at the bottom. These are little control buttons that are useful. There's a pause button, so you can see as I pause and unpause, it'll start and stop the simulator. The reset button literally resets. So if I hit the reset button, it'll start the simulator over. And I can pause when I want to. The parameters button opens up a display where I can adjust the parameters of the model. So basically all the elements I put into my sim file, like my field U with my tau parameter and my resting level and my beta value, I can access those directly and change them on the fly using the parameter button, which gets me to this menu. And you can see I can change the properties of the local excitation surround inhibition function here. I can change the properties of my memory trace dynamics, like the build and the decay time scale, etc. I can also hit the save button and save the parameters for this particular simulation. So let's say I was kind of tuning this field up on the fly and I changed some parameters. I could save that as a JSON file. And then I could load those parameters in later, which I'll show you when I get to the BAM file. So I can load parameters. So for example, in this simulations for this paper, I used some preset parameter values taken from another project just to kind of get myself started. And then we've got a quit button, which of course just quits the simulator. So you can see kind of a nice functionality built into the GUI. In order to create the GUI, let's look at the code. I'll just slide this over to the side so that we can see the GUI while we look at the code that actually was used to create it. So the first part of a GUI file basically defines kind of the window size, and this is the relative window size, and this is the field I use most, which basically says I want 3 rows and 1 column in the main part of my GUI. So I knew ahead of time I wanted one row for the field activation, that running history up here, a second row to display the time slices, the current time slice of the field activities, and then a third row for the interaction function. And then at the bottom, I wanted a command panel or set of buttons, command buttons, with these relative dimensions. And I wanted 1 row and 6 columns for the bottom panel, and that's, you can see I've got 6 buttons listed down here. So this kind of first command, which establishes the GUI, kind of tells you the relative layout of what you want up top and the relative layout of the control buttons. And then you have these last 2 elements, which we saw at the bottom of the sim file. And that's where I mentioned in the previous video that that collects all the objects in our simulator and makes them available for use in the GUI file, which is this one. Okay, then I'm going to basically create the 3 plots that I have. Okay, so the first one is the mesh plot at the top. To do a mesh plot in Cosavina, you use the multiplot function. And I'm going to be plotting 3 elements. I'm going to be plotting, sorry, I'm just noticing these are out of order. So the last element in any visualization in the GUI positions that element in the actual window. And you can see I've got this plot at row 2, column 1. So what I'm actually plotting here is the second element. Perhaps that's useful in terms of this tutorial to highlight that you can present these graphs in any order, and it's really this last element that controls where they appear in the visualization. Okay, so if you focus in on this second element, you can see I'm plotting the activation of field U, and I'm doing that in blue, the blue color. Then I'm plotting the output of field U in the red color here. So that's the sigmoidal output that you see in the display. And then the last element is the output of the memory trace, which I'm going to plot in the cyan color here. and that's what you see as the third line. Okay. This is going to be a scaling factor. So I'm actually scaling the sigmoid values go from 0 to 1. So I'm scaling that by a factor of 10 so that they show up nice and clearly on the display. So you could think of this as like I've got a right axis here, which is my scaled axis. And same thing for the memory trace. The memory trace values vary between 0 and 1. So I'm going to scale those on the display by a factor of 10. Again, that's like my second y-axis here is scaled by a factor of 10. I want my plot to be horizontal. You can set limits and set you can see I used a grid in this display for the x and y dimensions. This is my title or my label on the, yeah, that's my title. This is my label of my x-axis, label of my y-axis, and then the position. Okay, the next plot down is this guy. That's a surface plot. I am plotting the history of the field activities using an object called history trial that I created in the simulator. If you were watching that video, I think I said I didn't actually use that in the GUI, but in fact I do. So here it is. So the object I'm using is that history trial object, and I'm plotting the output of it, meaning the field activities. Again, I can scale the plot. It's a mesh plot. We can change the view, which is like the rotation of that plot. And then I've got my title, my x-axis title, and my y-axis title. And then the position in the GUI, which is position 1, 1, or row 1, column 1. And then the bottom plot is a kernel plot. I'm plotting the kernel, meaning the local excitation lateral inhibition function in the field. And then I'm also plotting the global amplitude, which is the global inhibition of that function. And those are plotted together. You can see some control of whether I want a grid or not, and I can change the axis limits there as well, and the color, and you can see give it a title and name the axes, etc. And then I position that in row 3 in the GUI. Right, so these are my 3 commands for my 3 plots. And then to plop the control buttons on there, it's pretty simple. I just included a standard set of control buttons that we use in a lot of our simulators. I literally copied this all directly from a prior simulator and just positioned them in the GUI. These will automatically be positioned in your control space, which you define up here by those parameters. And this tells me, as I said, I want in the control area of the display, I want 1 row and 6 columns of buttons, and then I'm just saying position those at column 1, 2, 3, 4, 5, and 6. So again, pretty easy to set up the GUI. Sometimes it can be a little fiddly, and you have to muck around with the display parameters a bit to get a sense for it. And again, if you need more help, I would refer you to the documentation file. I should also mention you can also get help directly by typing in the command in the command window in MATLAB. Let's check that out. If I go to MATLAB here, I need to quit out of my simulator, which I forgot was running. But I could say help, and let's say GUI.add visualization, and it'll give you a little bit of information there. Or I could similarly type help neural field if I want to refer back to the sim file as I was creating it. So that's just another way to kind of get some documentation as you are working through the different parts of setting up a dynamic field model.